All right, here we go. Number 8. It's the last problem of this set anyway. So we have a compressed spring this time. We have a compressed spring that has 20 joules of stored energy. The spring constant is 1500 newtons per meter. And we're looking for how far the spring is compressed. So this means that we're looking for x. Okay. So first, let's go ahead and draw a sketch of the string being compressed. All right, so we have our, let's just say ground. We have the thing that's attached to the spring, and we're looking for this distance, right? We don't know what this is, okay? And we know that the compressed spring has a stored energy of 20,000 joules, and the spring constant is 1500 newtons per meter. All right, and that we are looking for how far, so we're looking for the x value. And we know that the elastic potential energy is equal to 1/2 the spring constant times the spring stretch squared. Okay, and so we've got, let me see, make sure that we have our elastic potential is 1/2 spring constant times stretch squared. And we're trying to get the x part. We're trying to get this part. So we want this value to be by itself. So to do that, we're going to multiply by the reciprocal on both sides. This cancels that out, and we have 2 times the elastic potential is equal to k times x squared. We're not done yet because we got to get rid of the spring constant as well as the other x. So what we're going to do is divide by k on both sides. And we have 2 times the elastic potential over k is equal to x squared. We're almost there. And so this means that it's x times x, and all we want is just x. Okay, so remember that x squared is x times x, and when we're looking for x, we just want one of these, not both of them. So what we're going to do is we're going to square both sides, and we have the square root of 2 times the elastic potential over k is equal to x. So we have x is equal to the square root of 2 times EE over k. And we're going to replace the numbers with the things that were given here. So we have the square root of 2 times 20,000 joules over k, which is 1500 newtons per meter. And we're going to find the value of 2 times 20,000, which should just be 40,000. We're going to divide it by 1500, and that gives us about 26.66. And then the 6 is just repeating. And what we want to do then is find the square root of that number. Okay, so let me open up the calculator. So let me change the screen so you can see. All right, so we have 40,000, divided by 1500. And we want to find the square root of that number, which is going to be 5.16. All right, so that's going to give us approximately, let me move this back. So we have 5.16 meters. Or you can also just round it to 5.2 meters. That's fine with me, since it's an irrational number. All right. Now down to the proportional reasoning. Given the same spring constant, what is the elastic energy if the distance that the spring is compressed is tripled? So we're going to triple this. We're looking for this. We're looking for the elastic potential, which will go to the variable. 3 squared times 1 is going to be 9. So our coefficient is 9. All right, 9 times our original value of 20,000 joules is going to give us 180,000 joules. All right, next is the same spring constant. What is the elastic energy? So this is the thing that we're looking for. Stored if the distance of the spring is compressed is halved. So if we halve this, okay, remember that 1/2 times 1/2 is going to give us 1 is over 2 times 2, which is 1/4. Therefore, 1 times 1/4 is going to give us 1/4. And our coefficients will also be 1/4. So 1/4 times our original value, which is 20,000 joules. So 20,000 divided by 4 will give us 5,000 joules.